Okay, let's try experiment 2. I'm going to go through every step with you, and I've got about 15 minutes till my next class. I'm going to try to make this video and get everything together. We'll see if we can do it. All right, in this circuit for experiment 2, you're going to read a potentiometer. That's how you say it, potentiometer. So like how much potential is kind of what it's sort of coming from. So potentiometer. In this circuit, we will work with a potentiometer. You will learn how to use a potentiometer to control the brightness of an LED by reading a sensor and storing its 0 through 1023 value as a variable, then using it as a brightness level for the LED. You will need the microbit. Check, got mine. You'll need a micro USB cable. Check, got mine. 1 breakout with header. 1 breadboard. Here's mine. 8 jumper wires. I'll pause while I count out 8 of them. All right, so I counted out 4 red and 4 black because I looked ahead and I know that in the picture it's red and black. The color doesn't actually matter, but it does help you in staying organized so you know what's going where. Okay, so I've got 4 reds, 4 blacks, which is 8 jumper wires. And then I need 1 10,000 ohm. That's the one with the orange stripe. I have 1 of those, and it has the orange stripe. That's the 10,000. 1 LED, and there's a little caution on here. So I'll get that 1 LED. What's going to fall out first? And I get a green one. I'm going to go with green today. And 1 100,000 resistor, which is the one without the orange on it. So here we go. That's the 100,000 ohm. All right, that's everything that I need. Hopefully you got all your materials. Microbit, cable, breakout with header, breadboard, jumper wires, 10,000 ohm. Oh, potentiometer. I have to read that carefully. Potentiometer is the blue one. So you need the little blue spinny thing. All right, so I put away my resistor. It's not the resistor. It's a 10,000 ohm potentiometer, which is this little blue thing with a spinny knob on it. Okay, so here we go. Didn't get the suggested reading. We can do that. Introducing the potentiometer. A potentiometer is a resistance-based analog sensor that changes its internal resistance based on the rotation of its knob. But the potentiometer has an internal voltage divider, enabling you to read the change in voltage on the center pin with a microcontroller, such as the microbit. So what that means is power, electricity, is going to come in and it's going to have a certain voltage. And the potentiometer can sense what it is so that it can tell you what it is with your microbit. So that's why it says it's got an internal voltage divider, which takes the volts coming in. So your computer's going to have, when you plug your microbit in, your computer's going to have the power. It's going to send the power to the microbit through the little metal conductors in it, and it's going to go to the header, and those metal conductors are going to go to the breadboard, and underneath the plastic in those holes, which I mentioned before, in here, little pieces of metal. And we're going to make a circuit. You've got to have a full circle in order to get it to work. All right, so to hook up the potentiometer, attach the 2 outside pins to a supply voltage, 3.3 volts in this circuit, and ground. It doesn't matter which is connected where, as long as one is connected to power and the other to ground. The center pin is then connected to an analog input pin. So the microbit can measure the change in voltage. When you twist the knob, the sensor reading will change. All right, so it'll tell you, it says, note the potentiometer included in the kit has 3 marks on it that will help you figure out which breadboard rows the pins are plugged into. So what they're talking about, you can see it on one side. There's these little slits, so you can see it lined up with the pins. So you'll know which, when you push it down in, you'll know where it is. Oh, my light went off. Okay, the other thing is, if you look on that side with those little slots, on one side it says a 1, and on the other side it says a 3. If you twist it don't break it, but if you twist it and then it stops at the 1, And then, let me see if I can see this. So now it's pointing to the 1. And then if I twist it toward all the way to the 3, it'll stop again. So if I go halfway between the 1 and the 3, the arrow is pointing away from the side that has the slots. So the slots are here and the arrow is pointing away. Okay? All right, hardware hookup. Ready to start hooking everything up? Check out the wiring diagram and hookup table below to see how everything is connected. Don't forget we have polarized components. Pay special attention to the components' markings, indicating how to place it on the breadboard. Polarized components can only be connected to a circuit in one direction. So here is our wiring diagram. All right, note the full-sized breadboard power rails have a break down the middle. Right here it has a break down the middle. If you end up using the lower half of the power rail, you will need to jump between the upper and lower end. Oh, so they're saying right here, this is the break actually, right across. So if we're down here, we have to use a jumper to get down there. So the metal that is inside of the breadboard. So remember I said we make a circuit. When the power comes in, it goes into the metal. There's metal on this part, and there's metal down here. So if you need to jump in between one or the other, you need a wire to connect the conductors. All right, so I'm gonna zoom in, and this is the wiring diagram. So I've got my microbit plugged into my header, and I can zoom in again. And on the header, you've got the ground that goes to a jumper, and you've got the 3 volt connected to a jumper. And then we've got the resistor connected to the 0 pin. And then in the same row, if you look straight across, the power is going to come in here to the LED. So we're going to have the power coming in the red, and we're going out in the black to ground. All right, so we'll get the power coming in here, goes to the LED, and then here comes back out to the ground through the jumper. The other thing is on pin number 2, that's where our potentiometer is going to be set up, okay? So we're going to plug in the potentiometer somewhere up and down, and it's really important that our jumper cable goes from pin 2 into the middle pin of the potentiometer. That's where they said those 3 slots are going to line up, 1, 2, 3, and you got the middle pin lined up with our jumper. And then on the top side, we're going to go to ground, and on the bottom side, we're going to have the power line here. Okay, so that's going to be coming in and sensing it, and then going out to ground. And there's nothing else hooked up down here. And then we just have our 2 jumper cables up at the top. So we've got a ground line, and then we've got a power line. All right, so the red is the power and the black is the ground in this particular diagram. So I'm going to pause, I'm going to set it up, and then I will take a picture, and I'll give you a close-up of what I've set up. Okay, so once you go into make code, now I don't know which one you are, how your screen comes up, but mine always says I've started a project. It could be because I'm logged in. So mine is experiment 2, Potentiometer. Alrighty, and so then the code that we need is, we need a forever loop with set potentiometer value 2, analog read pin P2, analog write pin P0 to potentiometer value. Now, it says you need to set a variable is a placeholder for values that may change in your code, and you can create a variable using the make variable option underneath variables group. Set2, to store a value inside your newly created variable, you use set2 block. The set2 block allows you to select from a list of variables that exist in your program that you created, and then add a value that you want to store. Probably easier to hear me without my mask on, now that someone's not in the room. An analog read. In this program, you are reading the voltage from the potentiometer, which is 0 to 3.3 volts. The microbit reads that value as a 10-bit number, which is a value between 0 and 1023, using the analog read block. The analog read block is a value base block, meaning that you have to insert it into a block with a matching shape. We insert it into the set2 block. And the analog write, just like the read, the write changes deals with the range of values, but instead of reading it, it inputs the analog write block, outputs an analog value to a pin. And in this case, it's a brightness range for the LED, but it could be a tone from a buzzer, meaning it makes something louder or softer. a motor speed, making going faster or slower. So the potentiometer is going to ramp up or ramp down how quickly or how bright or how loud something could be. All right, so I showed you what mine looks like. And so now let's go ahead and do the code. So I'm in make code. And so it said we need a variable. So I'm going to click on variable and I'm going to make a variable. And now this one, it told us to do potentiometer value. Potentiometer value. And I think they said val. So I'll just name it the same way so it looks the same. When I do that, I get a potentiometer value, I get set it, and I get change it. Okay, now let me see what else I need here. So I set the variable. Now I need to set this to that. So I need to set the potentiometer value to analog read pin. So since I'm talking about a pin, okay, so since we're talking about pins, I'm going to go down to the pin, and it's analog, not digital, and I want to write the pin. So analog write pin, drag that over. So set to, I'm going to drag this right inside of analog read pin, that's the first one. So that was right, so let me grab the read. Analog read, that goes in here. There we go, clicks it right in where the 0 was. So we want it to say analog read pin P2, because that's where our wires were plugged into. And we want to write P0 to potentiometer value. So this here needs our variable, potentiometer value, drag that in there. So that's all our code. Now we need to download it. And then we need to, I know you're on a Chromebook, it looks a little bit different. Drag this onto our microbit. Oh, silly me, I didn't plug my microbit in. So I've got all the cables set up here, got it plugged into my computer. Plug it in, pressing in straight. There we go. Okay, now the microbit should pop up on mine. There it is. I'm going to drag it over. And I'm going to wait. I know the screen looks a little bit different on yours. It's going to say something like copying it over. Oh, mine lit up. Disk not ejected properly. I don't know why it does that, but it wasn't actually ejected. It's just the computer's telling us that it was. So the light is, where's the camera? Here we go, the light is on. This is the potentiometer. If I twist it to the one direction, goes off, and if I don't even know if you can see this. So I twisted it one way and it's off, and I twist the other way and it's brighter and brighter. So it's like a dimming switch for the LED. All right, I'm going to post some pictures along with this video so you can see where everything is wired in and get a close-up view. And hopefully you found this video to be helpful. Experiment 2. Good luck with you. Good luck with this. I got to figure out how to stop my video. Stop.